The moon is the most familiar object in the night sky. Every single human being who has ever lived has looked up and seen it. And for most of history, we assumed we understood it. A dead rock, geologically inactive, completely frozen in time, just sitting there, reflecting sunlight with nothing interesting happening beneath the surface. But the more we've looked, the more that picture has fallen apart. Because what's actually underneath the surface of the moon is something that nobody expected to find, and something that most people have never been told. The reason most people have never been told is because for a long time there wasn't much to tell. When we landed on the moon in 1969 and planting the flags, we were also placing seismometers on the surface, instruments designed to detect movement beneath the ground. And what those seismometers picked up confused scientists for years, because the moon was moving. Not violently, not in any way you would ever feel standing on the surface, but it was moving, and a dead rock is not supposed to move. When we started looking more carefully at the data coming back from those instruments, we realized that what we thought we knew about the interior of the moon was based almost entirely on assumptions we had never actually tested. We had studied the surface obsessively. Every crater, every rock sample, every gram of lunar soil had been analyzed. But the interior was essentially a blank, and filling in that blank took decades. What we found was not what anyone expected. The assumption had always been that the moon's interior was cold and solid all the way through. But when we finally had the tools to look properly, something sitting at the center changed that picture entirely. A partially molten iron core. The same structure you find at the center of an active planet, not a dead one. That single discovery rewrote everything. Because a molten core means heat. It means the moon is still slowly losing the energy it was born with 4 billion years ago. And we had been standing on the surface of it completely unaware. But that core didn't always look the way it does now. There was a period where it was much more active. And what it was doing during that period is something most people have never known about the moon. At some point in its early history, the moon had a magnetic field. Not a weak one, a genuine, protective magnetic field generated by that same iron core spinning fast enough to produce it. The reason that's so strange is because the moon today has almost no magnetic field at all. But the rocks on the surface tell a different story. When we brought lunar samples back to Earth and analyzed them, we found something that should have been impossible on a magnetically dead world. Those rocks were magnetized, which means at the point they formed, there was a field strong enough to leave a permanent imprint in the stone. And that imprint has been sitting on the surface for billions of years, waiting for us to find it. What the rocks told us about the surface was surprising. What they told us about everything underneath it was something else entirely. Beneath the crust of the moon sits a mantle, a thick layer of rock that makes up most of the moon's volume, and for a long time we assumed it was uniform. But the seismic data we've been collecting shows that the mantle of the moon is not uniform. There are regions within it that behave differently, areas that appear to be partially molten even today. Some of the most puzzling are what scientists call lunar mantle plumes, the same kind of structures that drive volcanic activity on Earth. And the moon is not supposed to have those. The surface shows no active volcanoes, nothing is erupting, nothing is visibly moving. But underneath the ground, the heat is there, still doing things we don't fully understand. The more seismic data we collect, the more structures like this we find, which keeps raising the same question. If this much is happening in the mantle, what is happening at the boundary between the mantle and the core? And what has all of that internal activity left behind beneath the surface that we haven't found yet? The thing is, the moon has been collecting things for 4 billion years, with nothing to wash it away, no weather, no atmosphere to burn anything up, and in the coldest parts of the surface, that means some of what landed there never left. Comets and asteroids have been hitting the moon since the beginning of the solar system, and a significant portion of those objects carried water ice. So when they hit the moon, that ice had nowhere to go. On most of the surface, it would have been vaporized by sunlight almost immediately. But there are craters near the lunar poles so deep that the sun has never reached the bottom. Inside those craters, the temperature drops to nearly negative 250 degrees Celsius, colder than almost anywhere else in the entire solar system. That cold preserved everything that ever fell into them. When we pointed instruments at those craters, we found water ice sitting at the surface. And when we sent an impactor crashing into one in 2009, the debris cloud that came up contained water, confirming what we had suspected for years. The moon has ancient water, potentially billions of years old, sitting in the darkest places on its surface, completely untouched. Suddenly, the moon looks a lot less like a dead end, and a lot more like a starting point. Everything we found under the surface, the internal heat, the water ice, the geological complexity, points towards something that space agencies are now taking very seriously. The idea that the moon's interior could actually shelter the first humans to live there long term. The water ice alone changes the entire calculation, because water means drinking water, it means oxygen when you split it, and it means hydrogen for rocket fuel. Everything you need to sustain a human presence on another world is sitting frozen in those craters, waiting to be used. And that's before you factor in what the interior heat tells us about the moon's geology. Because a moon that is still thermally active is a moon that is far more understood and more useful than the dead rock we assumed it was. And every mission we send there now is about figuring out exactly what the moon has and where it is before we commit to putting people there permanently. And Artemis 3 is exactly that preparation, the first crewed landing since Apollo, targeting the lunar South Pole, directly where the water ice is. For the first time, humans will be standing in a place we specifically chose because of what's beneath the ground rather than what's on the surface. And the instruments they're bringing are designed to tell us how much water is actually down there, and whether it's accessible enough to use. Every Apollo mission landed near the equator because that's where it was safest and most practical. The South Pole is neither of those things. It's one of the most extreme environments on the moon, but they're going there anyway because what's underneath it is worth the difficulty. And what those astronauts find when they get there will determine how serious the conversation about a permanent human presence on the moon actually becomes. The question now isn't whether the moon has more to give. It clearly does. The question is how much of it we're actually willing to go and get. So how far do you think we'll go with this? A permanent base? A refueling station? Comment below.